Hello all, this is Exidian. Um, this is my fourth major version of my moving item filter design. For those of you who don't know what a moving item filter is, I'll sum it up in short terms, but I do highly recommend checking out my first video on a moving item filter, Moving Item Filter 1.0. As it covers the concept more in depth and the inner details of how it all works. But a moving item filter takes in a feed of items from one belt, filters out one item from that feed. So in this top filter's case, it's filtering out anniversary cakes, and it puts all other items onto another belt. So with these two item filters, we are filtering out anniversary cakes and golden glow tulips, and filtering out all other junk, quote-unquote, items. So let's get into building it. For the clock and circuitry setup for the filter as a whole is a lot larger than the filters themselves, so we will start by building that. The clock takes up a 5 by 11 space, but the filters are 6 wide, so I would recommend finding a 6 by 11 space. Now, for the clock and other circuitry setup, we will need 5 electricity generators, 12 logic circuits, 8 cross circuits, 10 electrical wires, 2 pressure plates, and 4 electricity sticks. If optionally, you can have some torches for light or other light sources as long as they're not electrical. I recommend a lamp for making it easy to determine whether or not your clock is on or off. I also recommend color coding your pressure plates with some paintbrushes, and optionally, if you want, you can label those pressure plates in case you forget with some signs. So let's mark out a 6 by 11 space. We'll go a bit higher. 1, 2, 3, 4, 5, 6. So 3 tiles in from the left of your 6 wide. At the top of your 6 by 11 space, go 3 tiles in from the left. 1, 2, 3. On that third tile, place an electricity generator. Let me exit God mode. Place an electricity generator. You should have 3 tiles to the right of that electricity generator in your space. So first, let's start by making our clock. So we will place down a cross circuit, press E on to the right of the electricity generator, press E on it once to have it point downwards. Below the electricity generator, we will place down a wire, and in the nook between those, we will place down a logic circuit pointing right. Now, at this point, if we were to connect up the output of our logic circuit to the only available input left in the logic circuit, it would create a 2-tick clock, that is 1 tick on, 1 tick off, or a period of 0.1 seconds. Now, this doesn't look like 0.1 seconds. There are visual glitches in CoreKeeper at the moment that make it very misleading, but believe me, this is 0.1 seconds. However, a 2-tick clock will cause our drills to break our tables and chests, so we cannot use a 2-tick clock. We can, however, use a 3-tick clock. To turn this into a 3-tick clock, get rid of the wire that was connecting it, so it should just look like this, what we had originally. Place a logic gate on the right of the logic gate you just placed, but this logic gate faces downwards. Above that logic gate, place an electricity stick, like so, and then we will place a wire below that logic gate. Now at this point, if we connect it up, it is a 3-tick clock, but we don't want to connect it here with a wire. because we're going to add some other circuitry to this as well. So instead, let's connect it with a cross circuit and press E on it once to change the orientation. Okay, moving on. So in addition to this clock, we want the ability to turn it off. Now there are a number of ways that we could turn it off, but we will simply set up a T flip-flop to connect to the clock. The T flip-flop is not the simplest way to turn it off, but we will need this T flip-flop for other reasons, so we're going to go with that option. So the first thing is below this wire that we have placed that is below our generator, and also consequently to the left of the cross circuit we just placed, we are going to place down a logic circuit pointing right. Now to the left of that logic circuit we will place another logic circuit pointing right. To the left and bottom of the logic circuit we just placed, we will place down electricity sticks. Above the logic circuit we just placed, we will place a cross circuit, and above that we will place a pressure plate. Let's color code our pressure plate. I will paint it red, and we'll give it a sign that says clock on off. You can have it say whatever you want, but that's what I'm going to make this one say. Now this is not yet a T flip-flop, it is simply a one-tick pulse generator. In order to turn it into a T flip-flop, we do need to connect the output of this logic circuit back in on itself. So we will place to the right of the bottommost electricity stick that we've placed thus far, we will place a logic circuit and press E on it once to put it in the correct orientation. Then we will place to the right of that, and consequently in the nook between these two logic circuits, we'll place a wire, and then I would recommend placing a bulb on top of that. Now, people more experienced with circuitry might know that a bulb on its own can count as a wire, so you don't need the wire. I do highly recommend having the wire. If the bulb were to break, so would your clock. So having the wire and the bulb gives you a bit of a safety buffer there. So now if we step on our pressure plate, we will see that the T flip-flop turns on, and if we step on it again, it turns off, on, off, etc. So now we need to connect our clock and our T flip-flop. We will do so by putting a logic circuit in this little nook here, like so. So now, on, electricity passes through once every 3 ticks, 1 tick for every 3 ticks, and then off, no electricity passes through. That is our clock. Now, there are also some other things that we need to add. One of those things is we will need the ability to manually trigger a 1-tick pulse that is not attached to our clock. So let's set that up now. So first things first, below our bottommost electricity stick, let's place a logic circuit pointing downwards. To the right of that electricity stick, we will place, to the right of that logic circuit, we will place our last electricity stick. To the left of that logic circuit, we will place our last pressure plate, and I recommend color coding it. I'm color coding mine yellow. And we'll put a sign down, and this sign will say manual 1-tick pulse. Now this is indeed a manual 1-tick pulse, but currently it doesn't connect anywhere. So let's fix that. We're going to add a wire below our logic circuit, and to the right of that wire we'll add a cross circuit. To the right of that cross circuit we'll add a logic circuit. And to the to the right of that cross logic circuit we'll place a wire. Now we will add what we want to do is we want to make sure that this, the output of this 1-tick pulse generator does not reach the rest of the circuitry unless the clock is off. So first, let's make it so it does not reach it unless the clock is on. Sounds counterintuitive, I know, but it is the most direct way of doing so. So we will add a logic gate in this little nook between our logic, we'll add a logic circuit in this little nook between our electricity stick, our logic circuit, and our bulb, facing downwards into our logic circuit, like so. We will add a cross circuit to the right of that logic circuit. And now, if the... actually, let's get rid of the cross circuit for a moment to demonstrate. If the clock is on, our 1-tick pulse generator will now pass all the way through. It doesn't look like it, but it will. Now, in order to make it so that it doesn't pass, it passes through when the clock is only when the clock is off, we will add our cross circuit in this little nook here, and then a generator to the right of that. So now, when the clock is off, the electricity will pulse through, but from our manual 1-tick pulse. But if the clock is on, the electricity cannot pulse through because nothing is powering this logic circuit here. So that is the clock and tick generator. Now we need to set up the lines, the line split, as it were. So the line split is going to feed into our filters. So let's start with that. So below our bottom right electric wire, we will place down another wire. Below that, we will place down a cross circuit, and below that, we will place down two more wires, like so. Now, we're going to split our thing to the left from here. So below the to the left of the cross circuit, we're going to place a generator down. To the left of that generator, a wire. Underneath that generator, a logic circuit pointing left, and to the left of that logic circuit, another logic circuit pointing left. This ensures that our left line and our right line are 2 ticks apart, which is important. To the left of that logic circuit, we'll place a wire, and then below that wire, we will place a logic circuit pointing downwards, like so. A generator to the left of that logic circuit. And then on the right line, we will place down a generator to the, a logic circuit below the right line. And this is why you want to measure out your space. I accidentally made a mistake and didn't measure out enough space. There we go. Oops. Good enough. We will want to add a cross circuit to the right of the logic circuit and a generator to the right of that. Now this cross circuit is not strictly necessary for this part. However, part of this logic circuit with its generator, this logic circuit with its cross circuit and generator will be repeated every 3 item filters that you stack on top of each other, and so I figure it's best to just leave it here for reference later on. So even though this cross circuit isn't strictly necessary, I do recommend that you keep it anyways. So that is our setup circuitry for our filter. I'll just stand here a moment so you can take a screenshot. Alright, so, let's put down, just for benefit, we'll put down some torches. That ought to be good enough. Okay, so next is the filter itself. So, let's get a bite of cake and crack on. So, the filter. For the first filter and the second filter, you will need the following materials: 6 electrical wires, 5 robot arms, 2 drills, they can also be crude drills, 3 conveyor belts, a double wide chest. I recommend Glurch chests as they're very easy to farm, but you can pick any double wide chests you want. A 2x2 table. I recommend wood tables as you can craft them and you can't craft other types of tables. But you can once again use whichever you want, but should be double wide. Like 2x2, sorry, not double wide, 2x2. And then in addition, you will need 6 filter items. The filter item is the item you want to filter out from the junk, and 35 filler items. The filler item is an item that will not enter your item filter system. So dirt blocks are good, and we will use them for our first one, but I actually recommend, instead of dirt blocks, wooden shovels. There is a good reason to use wooden shovels. There are actually 4 or 5 good reasons to use wooden shovels. The first is that wooden shovels are not stackable, and as such, if another wooden shovel enters your filter, it will not get caught in the filter and will instead pass right on through. The second reason is that wooden shovels can be crafted without a crafting table. They are one of 2 unstackable items that are in your crafting menu. The third, wooden shovels only cost 4 wood. They are one of the cheapest unstackable craftable items in the game. And the fourth and final one is wooden shovels are good for debugging. At any time you could simply, if something goes wrong, you could take a wooden shovel out of one of these chests, and if you were to normally just try to break, say, this wire here, it's possible that you'll break the electricity generator instead, but a wooden shovel will allow you to accurately pinpoint what part of the circuitry you are digging up. Let's put those back. So that is why I recommend wooden shovels, and for the extension we will be using wooden shovels. Now, it is also recommended to have 1 or 2 additional items, additional filter items to use for testing. And lastly, torches for light can never go wrong. So with that, let's get into it. Now, the wiring for the filter is far simpler than the wiring for the clock. It is, after all, only 6 wires. So let's start placing those 6 wires. First, coming out of your left path, you will want a wire below the logic circuit. Coming out of your right path, you will want a wire below the logic circuit. Then we will place 2 robot arms. 2 robot arms will be placed, but for now we will just place one of the robot arms. It'll go to the left of the wire you just placed, and it will be pointing right. Below that robot arm we will place 2 wires, like so. And then lastly, to the right of that we will place a drill facing upwards, and a robot arm facing leftwards, like so. Below that drill we will place 1 wire, and then on the left path, below the wire we placed, we will place a drill facing rightwards, a robot arm facing upwards into the drill, and then another wire below that, like so. Lastly, in this little crevice between the 2 wires, to the right of the top wire, that is the wire below the downward facing logic gate of the left path, you will place a robot arm facing upwards. This will act as our input arm. Now there is 1 arm left over, and we will get to that, but first we need to set up the rest of the filter. In this nook between the right-facing robot arm and the upwards-facing drill on the right path, we will place a table. On that table, we will place 4 of our filter items. In this nook between the upwards-facing arm, the rightwards-facing arm, the other upwards-facing arm, and the rightwards-facing drill, we will place our chest. Into that chest, we will place 1 of our remaining filter items, so you should have 1 filter item left over and potentially some others for testing. Into the remaining 35 slots, we will place our 35 filler items. Like so. And then lastly, we actually need, although this robot arm is in the correct spot and in the correct initial orientation, we do need it to go through half of a cycle. In order to do that, we will manually 1-tick pulse the arm once by stepping on the 1-tick pulse pressure plate. Now, it has picked up an item, but it has not yet dropped it into the chest. Remember that there was already one here, so it's currently holding it above the chest. It's a little hard to see, but it is holding it. Now, we will replace the item that it took from the table with our last filter item. And in the spot below the arm, on top of the wire that's below it, we will place a robot arm facing left into the chest, like so. Now, if we turn on the clock, our filter, there are a number of ways that these middle arms will look like depending on what tick you turn the clock on. It's irrelevant. What matters here is that you have one item that may or may not be flickering in and out. You've got the 4 in the chest, and the way you can test it is by simply putting your filter items here on the input, and you will see them go to the right on the output. Now, for extra testing, we will throw some other item, garbage item, and we will see that it goes to the left. Now we're almost done. We just need to set up some conveyor belts. If your filter is heavily loaded, it is possible that some items will make it past this arm here and go into this square that I'm standing in. So we will put a conveyor belt pointing back into the drill. Same with this drill, we will have a conveyor belt pointing up into the drill. And lastly, when that arm deposits the junk items, they end up here, but we need them shifted 1 to the right to go to the next filter. If this is your last filter, you can feel free to point them to the left with your conveyor belt, but if it's not your last filter, point it to the right so it can get picked up by the next filter. So this is a completed item filter. Now, let's build the second and the third one. I will go through the second one a lot faster. The third one will be a bit slower. So first, let's collect some items to filter with. That should be good enough. Alright, so items for our second filter. Let's just build it up real quick. So we have our input arm, to its left a wire, below it a rightwards facing drill, below it another robot arm, to its right a chest, to its right a robot arm facing right, to then to that robot arm's right a wire, then a table, a table, let's first rule, my bad, is definitely you want to turn off your clock when you're building the next filter. So 4 items in the table, 1 item in the chest, and actually let's go get those shovels. There we go. Okay. And then we want wire, wire, drill, arm, and then wire, wire. Let's break this temporarily, rebuild it later. Okay, that should be enough space. Alright, and then we want to half cycle. Now, if you want your arms all facing the same way, they should, when the clock is off, the arms should be facing right into the table. So if not, you can just break the one arm you just placed, replace it, and then half cycle again. So now they're all facing the same way. I do like that, though visually it doesn't, it's only a visual thing. It doesn't affect the outcome. And then finally, our last robot arm facing left, and our 3 conveyor belts. Now, just to test, let's turn the clock back on, and we'll throw in our new filter item, and it works. Cool. So, right, so let's do the third one. So the third one is a little different. We've got our stuff. I have an extra chest that we broke. Let's just go put this back. Okay, so for the third one, instead of 6 wires, we have 4 wires, and in place of those 2 wires that are missing, we have a cross circuit, 2 logic circuits, and 2 electricity generators. So other than that, it's the same: 5 robot arms, 2 drills, 3 conveyor belts, a chest, a double wide chest, and a table. So let's build it. Real quick, this shouldn't take too long. It's all mostly the same. We've got the input arm facing up, to its left the wire, below that a drill, below that a arm facing up, to the right of those a chest, to the right of that let's actually turn off our clock. Right, don't make that mistake again. Clock is off. Cool. To the right of that a robot arm facing right, to the right of that a table. Into the table we will put 4 filter items. Into the chest we put 1 filter item, and apologies, I seem to be missing my my filler items. Let's just get 35 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 35 wood shovels. Okay. And then wire, wire. Drill facing up, robot arm facing left. And let's 1 tick pulse Am I missing something? I have an extra wire. What am I missing? Did I forget? Ah, yes, I forgot. Wire there that goes under the table. There we go. Much better. Let's, there. Alright, so then we do our 1-tick pulse. We set up our last arm. We put in, we refill that spot in the table. And we do our 1, 2, 3 conveyor belts. Now, here is the difference between, so the electricity signal from the top will not reach to the 4th filter. So my recommendation is after finishing every 3rd filter, you, instead of those 2 wires, you build your extender. So let's do that. So for the extender, let's dig up our these 2 conveyor belts, and we will build that. So below this wire that's in the corner here, you will put down a logic gate facing downwards to the right of, sorry, my bad. Below the drill that's facing up into the table, you will place a logic gate facing downwards. To the right of that, a cross circuit. To the right of that, a generator. Then you can go ahead and put this conveyor belt back. Actually, we'll leave it for now, but we'll put it back eventually. And then below the arm on the left path, you'll put a logic gate facing downwards and a generator to the left of that. Like so. Now we'll put the belts back. Oops. There we go. Alright, so that is what you should do every 3rd filter, is set up your extenders for the 4th filter. Even if you don't think you'll need one, it's not much extra material, it's absolutely worth it. So let's turn on our clock, and we'll get our other resources, and let's see if everything worked according to plan. Okay, we can see the junk item ended up here, and each of the filter items ended up in their appropriate spots. Now, usage. It is very, very important that you understand this. If the clock is running when you unload the world, this filter will break. I will demonstrate with this left clock. I will turn it off before I unload the world, and with the right clock, I will leave it on so you can see what I'm talking about. Okay, so you can see these chests are now empty. This is a sign, it's not the only sign, but this is one of the signs that your filter is broken. In order to fix it, let's unpause the world and disable God mode here real quick. You will need to break your arms, and you don't have to rebuild the rest of the filter, but you will need to break your arms and go through the setup step again. So, robot arm down, robot arm down facing, put it down facing right, and other robot arm down facing right, all these facing right. We step on the 1-tick pulse generator once, and then we need to go in from the left side, that's where you'll have space. Or the right side, I suppose, either side works. And then robot arm facing left, robot arm facing left, robot arm facing left. Now, we want to put our filter items back. One goes on the table, and one goes back in the chest for each one. In the chest. In the chest. And then go back and do these tables. On the table. On the table. So now it should work again. If you do not do this step and your item filter is broken, it will cease to work, and your tables will get filled with junk items, and junk items will seamlessly pass through your filter in ways that they shouldn't. Now you might notice this clock was on when we exited the world. It is now off. This is by design. In case your filter is broken, this allows you to fix it easily. What this does mean is that you will need to turn the filter on yourself whenever you log in the world, and turn it off whenever you're going out of the world. But now we can see, if we put down some items, we can see that it is once again working as designed. Junk, filter item 3, filter item 2, filter item 1. Now as you can see, these don't quite look the same way they did before, and visually, depending on when you turn on the clock, you will see flickering in your box. Note that this is fine. No amount of lag will cause problems here due to the way that this whole thing has been set up. But yeah, that's the moving item filter. Now, in the past, I've made this mistake, so from now on, I'm going to put be sure to read the description of the video or pinned comment of the video prior to building this, as it's possible that I've made mistakes and will post corrections in there, since I cannot change the video once it's on YouTube. So yeah, keep that in mind. Pin comment and description for any corrections, updates, or answers to frequently asked questions. Thank you.